Greetings, class. I was right at the very end of problem 7.2.27-T, talking about whether we should reject the null hypothesis or reject or fail to reject our null hypothesis. Our test statistic is negative 0.51. So based on all these sample statistics and that standard deviation, I got a z-value, a standardized test statistic of negative 0.51. Now if you look over here, the boundaries are at negative 2.32 or 33 and positive 2.33. Those were our critical values. So if we are inside, in this case, if we are inside this area, then we know that we're not going to reject. So we would have needed something less than a negative 2.33 or a test statistic greater than 2.33 in order to reject H sub O. So in this one, we fail to reject H sub O at the alpha is 0.02, so that's our significance level. So we fail to reject. Our claim was the null hypothesis, so there is not enough evidence to reject the claim. So we fail to reject the null hypothesis. You have to realize that the null hypothesis was our claim. So if we fail to reject the null hypothesis, there's not enough evidence to reject the claim. So we'll check that. And we're ready to go to another question. So we're going to look at one more question while we're looking at section 2. It says use technology to help you test the claim about the population mean mu at the given level of significance alpha using the given sample statistics. Assume the population is normally distributed. So our claim is mu, the mean, population mean, is greater than 1,290. Now this is not an equality statement. It's greater than. So that has to be our alternative hypothesis. So you have to look for mu greater than 1,290 for the alternative hypothesis. And the only one that has mu greater than 1,290 is F. And then we have to verify that its complement is less than or equal to. So these are our null hypothesis and alternative hypothesis. And in this case, remember, we'll look at this later, this is our claim. So we have to calculate the standardized test statistic. Now remember, to calculate the test statistic, we actually have to run the z-stat, one sample z, with summary. The sample mean was 1307.24. The standard deviation was 214.69. I got that from this sigma, 214.69. And the sample size n is 275. We are doing a hypothesis test. Mu is 1290, the mean is 1290, and our alternative hypothesis is greater than. Now you notice that it does not change the symbol for our null hypothesis, and that's okay because the test statistic is going to be based on the symbol for the alternative hypothesis. So as long as that symbol for H sub A is the same, this will work out. I'm going to store it in the data table just so I'll have it to look back at later. It says the Z statistic, the standardized test statistic, is 1.33 to 2 decimal places. Now the p-value, The nice thing about it is that this one gives you an associated p-value with that z statistic. Since this was a right-tailed, then that p-value should be the same. So let's go ahead and type this in, 0.091, 091 to 3 decimal places. That 4 means we leave the 1 as it is. And then we determine the outcome. Now, I can compare this p-value to my alpha value. Remember that if p is less than alpha, we reject the null hypothesis. But when you look at this p-value, 0.09, that's greater than 0.05. So we fail to reject because p is greater than alpha. So at the 5% significance level, there is not enough evidence to support the claim. The claim was the alternative hypothesis, and the only way you could support that is if you reject the null hypothesis. Since we failed to reject our null hypothesis, there's not enough evidence to support the claim that the mean is greater than 1,290. So when you work these, there's going to be a lot of issues about the wording based on whether the claim is your null hypothesis or the alternative hypothesis. Greetings, class. There is another question that's going to be on your homework that provides data rather than a summary. And we can only do part of this using data. So the first thing you're going to do with this data table is you're actually going to copy it, because this is what you'll have to do on a test. Do Control-C and then come over to StatCrunch and do Control-V to paste. Now I have this data. It says the length of time in years it took a random sample of 32 former smokers, so you can see that there are 32 data values. To quit smoking permanently are listed. Assume the population standard deviation is 5.2 years. We'll need that. At alpha equals 0.02, is there enough evidence to reject the claim that the mean time it takes smokers to quit smoking permanently is 13 years? Now, they use the word is. Mean is 13 years. So that's an equal statement. So if the null hypothesis is equal to 13, then the alternative hypothesis would be the complement to that, which would be not equal. So this should be your null and alternative hypothesis. Now, it wants us to identify the standardized test statistic. So we need to find the mean of this column of data. So I'm going to do summary stats for columns, variable 1, and all I need is the mean. Now I'm going to go ahead and store it in the data table so it'll be there. So the mean for this sample is 14.83. I still haven't found the standardized test statistic, but I can do that now. I can go stat, z-stat, one sample, and I'm not going to do it with data. I have to do it with a summary because the data doesn't use the standard error of the mean that you need. So with summary, I have to use the sample mean, so that's why I had to find the mean of that data, 14.834375. I had to find the mean of the data. The standard deviation they gave us, population standard deviation, is 5.2 years. So you have your 5.2. Your sample size, there were 32 former smokers, so your sample size is 32. We're testing a hypothesis of mu equal to 13. And I'll put that in the data table, store it in the data table, and it says that our Z statistic is 1.9955, or if you round that to 2 decimal places, that 5 is going to make that 9 go up to a 10, which makes that's going to go to a 0, a 2, so it's actually 2.00. Then it wants the p-value. Now this is something I wanted to talk to you about because you notice that this is a not equal, which is a two-tailed. However, StatCrunch knows that your hypothesis, your alternative hypothesis, was two-tailed, and it calculates the two-tailed value. So you don't have to do anything to this particular number. You just type it in as you see it, 0.046. That 5 becomes a 6 due to the 9. So we have 0.046. And again, if you need to see that, I'll pull that table back up where we did the one sample Z summary, and you notice that it showed that H sub A was not equal. So StatCrunch knew that this was a two-tailed test and adjusted the p-value accordingly. Now let's compare our p-value of 0.046 to the alpha value of 0.02. Notice that this p is greater than alpha. Now if you remember from your text that, oh goodness, sorry, I went too far up. If p is greater than alpha, in this case 0.046 is greater than 0.02, then we fail to reject H sub O. So we're going to fail to reject H sub O, but then we have to decide what that tells us. Remember that H sub O was your claim. So we fail to reject that H sub O. This one says there is sufficient evidence to reject the claim. But the claim is H sub O, so you don't have any evidence to reject that claim. So fail to reject H sub O. There is not sufficient evidence to reject the claim. Since the claim was H sub O and we fail to reject H sub O, then there's not sufficient evidence to reject the claim. So that would be our answer C. I'm hoping that you find this helpful. Please feel free to contact me if you have questions or concerns about any of the other problems within Chapter 7, Section 2.